Welcome back, welcome back, welcome back to science. All right, so we're going to be talking about blood groups and transfusions. So in 1910, these were identified as the ABO blood groups. So if you remember back to genetics in 101, that we identified this as something that's going to have multiple alleles that are going to be involved in this. And so blood types are going to be distinguished as type A blood, B, AB, or O. Each one of those have a positive for Rh or a negative for Rh. Safe transfusions require blood types of the donor and recipient and cross matching. And so this is going to determine whether it is okay or not for them to receive this type of blood. And if you have a negative reaction, it's going to cause something called agglutination. When you get the wrong blood type transfused, it does not cause clotting, it causes agglutination. Agglutination is going to be a clumping together of cells. So within these cells, you have antigens, and an antigen is going to be something that's on the cell surface. You can think of it as a name tag on that cell that identifies the other cells as like, hey, it's that type. So, blood type A, they all have the A antigen. On their surface, there's a protein that is marking them as being A antigen. So that's a name tag that all of the red blood cells have. With type A, they have an antibody for type B. So if you give a type B blood to a type A blood individual, then they're going to have agglutination, and this can be a fatal condition. So agglutination is going to be the clumping of the red blood cells, and this is due to the antibodies for that other type that's present. So if you have type A, then you would have the antibodies for type B. If you're exposed to type B, you would have agglutination. So the symptoms of agglutination, you're going to have anxiety, breathing problems, uh, facial flushing, headache, severe pain, and perhaps even jaundice. And once again, it can be lethal. So the type, based on the presence or absence of major antigens or red blood cell membranes, you have the antigen A and antigen B. Once again, these are cell markers. They are carbohydrates that are going to be attached to a glycolipid on the cell membrane. This is going to allow for individuals to identify the other type. A person with type A will have the antigen A and the antibody for B in their plasma, so they can take out B if they ever see B. So here are the blood types. A has A antigen and a B antibody. B has B antigen and A antibody. AB has A and B antigen, and it doesn't have any antibodies. O has neither A or B, but it has antibodies for A and B. So if you go through and look at the percentages of the different breakdowns in the US, Caucasians, 45% of them are type O, 40% are type A. And you can see that B and AB, respectively. And you can see the different um, blood groups by ethnicity as you go through and look. And this is just what it is. This is the statistics of the different populations by ethnicity. This is showing antigen A. Notice they have antibody B. So if it sees B, it will take B out. Here is antigen B and antibody A. Notice that the tips are different. These antibodies are going to have these heavy chains that are going to, short chains that are in that are going to be variable, that are going to become specialized for what they're going to take out. Here is type AB, and notice that AB doesn't have A or B antigen, and notice that type O has both. And also notice that type O doesn't have any antigens, but it's going to have antibodies for both. And type AB has both antigens, but doesn't have antibodies for either. This is what agglutination looks like. So let's go through the different types of donors and recipients. What I recommend is that you make a table and go with the different blood types A, B, AB, and O, and then go with can give to, can receive from, and make that table as you go through. So O is the universal donor, and it's the universal donor because it doesn't have any antigens on its cells. So it can give to any cell without having any kind of reaction, agglutination of the recipient. So O lacks antigens A and B, so it can be given to anybody, making O the universal donor. And so if you're giving blood and you're type O, you're in high need because you can give to anybody with A, B, or O blood types. We'll get to the plus and the minus in a minute with the Rh factor. Now, with AB, AB is going to have antigens for both A and B, but as we remember, it doesn't have any antibodies. And so AB can receive from any blood type. O doesn't have any antigens on it, so it's not going to cause a reaction. So it's a universal donor. A and B and AB can be given to type AB blood. So the two extreme opposites, O can give to anyone, AB can receive from anyone. So that would put O as the universal donor and AB as the universal recipient. All right, this is the blood types by recipient, by donor, and let's talk about this. If you have Rh positive, so Rh is referring to this rhesus factor. And why I'm saying rhesus, it referred to research that happened with a rhesus monkey. And some individuals have this protein, some don't. If you do, it's shown as a positive, like, hey, Rh plus, you have it. And some don't, and it's Rh negative. Don't think that we got a disease from a rhesus monkey. This is we share a similar protein as a rhesus monkey, as we're over 96% like a rhesus monkey. It's okay. I'm not calling you a monkey. This is just saying evolution is saying statistically, analyze the DNA. We are 96 plus percent like a rhesus monkey. And it's more like a 98% like them. So to say that we have a protein in our blood that's similar, not surprising at all. Some people have it, some people don't. If you have it, it's a plus. And that would, you would say, let's say you have O blood, but you have this factor, this protein factor, you would have O positive. If you don't, you're O negative. People that are negative can give to a negative or a positive. Example, type O blood can give to an O negative or an O positive. But if you're O positive, you can give to O positive, but you can't give to the O negative. So the Rh negative people cannot receive blood from positive individuals. And so if you go through and even further refine that table, now we can appreciate it a little bit more on who can give to what. Notice that A positive can receive from O negative, O positive, O A negative, as well as A positive. And so this is the preferred donor. This is like the perfect match, is the exact same thing. So all of these are options: A positive, A negative, O negative, O positive. Notice that O is on every one of these lists. O negative can give to O negative, so that's the only one that can be there. So this is that permissible blood type, and as it refines, and I talked about those are questions that oftentimes like to ask on exams. All right, erythroblastosis fetalis, or hemolytic disease of the newborn. All right, so here's the scenario. A mother is Rh negative. And an Rh negative mother is going to conceive a baby, and that baby may be positive or negative. And a person has to have two negatives to be negative. And so she may like say, hey, the father's right here, and his blood type is negative, and I'm negative, so I'm good. You guys wouldn't believe this, but sometimes people lie, and that's not the father. You can ask Moripovich about that, and he will confirm that, yeah, sometimes they are not the father. So instead of allowing the woman to have, make a decision like, yeah, I need to come clean or not, the physician is not really going to go there. They're going to say, like, oh, you have a negative blood type, A negative, B negative, O negative, AB negative. Then they're going to give you something called Rogam. Rogam is going to be a medication they give at birth for people that are Rh negative. And you may like, but why are they doing this? Here's why they're doing that. A baby, when it's born, will have fetal blood as well as maternal blood, and they're going to mix. Until this time, they don't really mix. So the mother has now been exposed to potentially Rh positive blood. The mother's immune system will identify that foreign substance and develop an immune response to it. And so the first baby, no problem. But second time, she will get late term, and in childbirth, the mother will identify that positive Rh and develop an immune response to it, which will kill the baby. And you're like, oh my gosh, that's horrible. Yeah, it's our body's natural mechanism to protect itself. So ROGAM causes the body to not recognize the Rh positive blood that could potentially be coming from that baby. If the mother is Rh positive, let's say she's O positive or A positive, B positive, AB positive, no problem, because she won't develop a response to a negative, because the negative is the absence of it. It won't be even identified as a problem or a threat. But an individual who is Rh negative will then have an immune response to that. You can see the antibodies that's going to be there. So when the mother identifies this, she'll be ready to terminate the next pregnancy as a result of that. And so this is Rh incompatibility that happens. And this is just a normal medical procedure for people who are Rh negative. They lack that, and their body develops an immune response to that. And you can prevent it, and it is prevented. It's standard procedure to give an Rh negative mother ROGAM as she is getting ready for childbirth. All right, guys, this is going to sum up our section. And once again, thank you, and I look forward to seeing you soon. So long.